Today's lecture, we're going to talk about more exponential rules. Last lecture, we went over these 4 rules, and I'm adding a few more. And make sure we memorize that. So first thing that we need to understand is that any number to the 0 exponents is equal to 1. So even 100 to 0 exponent will be 1. Right? This is having negative exponents. So in order to get rid of negative exponents, you flip the base. So numerator become denominator. Because the negative exponent is same as flipping this one, a to the negative n exponents, get rid of negative, it will become a denominator. Denominator b to the negative n's exponents, get rid of this negative, will become on the numerator. So flip the base when you're getting rid of the negative exponent. So same thing on this one. So this is based on the negative exponents. So if you wanted to get rid of this negative exponents to positive, all you need to do is flipping the base. A on the numerator become denominator, denominator b become the numerator. And the last one we wanted to go over in this session is that a to the m's exponents over a to the n's exponents. So this have a same base, just different exponent divisions is same as the subtractions. So I like to put this with the first one, where when it's a multiplication with same base, you're adding. So division of the same base, you're going to subtract, so that those two are related. So using those rules, we wanted to go over a few problems. So let's look at the first one. It's evaluate 60 to 0 exponents. 60 to 0 exponents. Any numbers to 0 exponent, we say that's equals to 1. So does that mean this is going to be the second problem? B is going to be 1 also? Well, not really, because this exponents only apply to 60, not to the 0 exponents. So exponent itself is only applied to the number, not the signs, unless you have a parenthesis like that. So this exponent is applying negative 60, but this exponent, 0, is only applying 60. So you could say you have negative 1 and 60 to 0 exponents. That's what it means on the B problems. So it means you're going to have negative 1 times 1, which is going to be negative 1 on that problems. But because the whole number with the sign is 0 exponents on C, this is going to be 1. And D, this is going to be 6 to the first exponent and y to the 0 exponents. So only thing that have 0 exponent is variable y. So 6 will stay as it is, but y to the 0 exponent become 1. So your solution of that problem is going to be 6 times 1, which is 6. Let's look at example 2, simplifying. What about if we have 3 to the negative square? So whenever I have negative exponents, then I will try to get rid of that negative first. And we understand in order to get rid of negative exponent, you flip the base. So this one right now is 3 over 1 to the negative square. So if you wanted to flip that base to get rid of negative exponent, it will become 1 over 3 square. Because I flipped, I do not need to write negative signs on the exponent anymore. The next one, so in order to get rid of negative, flip the base. So this is going to be flipping 1 over 2, so it will be 2 over 1. which is going to be 2 cubed. That's 8. The next one, this negative exponents only apply p, not 3, right? I don't see any grouping, so only applying to p. So you're going to get 3 times p to the negative square, which is 1 over p square. And if you wanted to write it in simplest form, you can combine this, which is going to be 3 over p square. The next one, in order to get rid of the negative exponents from the numerator, the base on the numerator will become on denominator and get rid of negative. E, I see y to the negative fourth exponent, so that's going to be same as 1 over y to the fourth exponent. So that's the only part that it's going to be flipped, not the x. And you wanted to write it in the simplest form, which is going to be 1 terms. So when you multiply this, it will be x cubed over y to the fourth. The next one, I can get rid of negative exponent by flipping. So on the numerator, m will become denominator. And the p on denominator become numerator when you're taking the negative sign. And since we don't need to write the 1 as exponent, it will be just p over m to the fifth exponent. So it will be the same thing for G problems. The one without the negative, I will just leave it as it is. So I have b right here on the numerator and 3 on denominator. But the one on the numerator with the negative exponents, when I take that negative, a will become on denominator. And the one on the denominator, get rid of negative, will become the numerator. And I don't have any like base, so not the same letter, so it will stay as it is. If I have a same base, I need to combine them to make it 1. So whenever it says simplify, you need to make sure there will be 1 of the letter or 1 of the each term, and you wanted to get rid of the negative exponents. So the last one, if you wanted to get rid of negative exponents, flip the base, and then look like I can distribute, right? I can distribute into multiplication and divisions. When you simplify this, 2 to the fourth exponent is 16, y to the fourth over x to the fourth. Example 3, we're still simplifying. This time, what if we have a same base? So you can see you have 5 and 5 as base. Only thing different is exponents, and this is divisions. So this time, you should be able to write it as 5 to the 8 exponents minus 6. Remember, if same base and that's divisions, dividing, is same as subtracting your exponents. So that's going to give you 2, which is 25. And I can even show why that is, right? So if I write 5 8 times on the numerator, you have 6, 5 on denominator. Then matching ones will cancel out each other from numerator and denominator. So all this cancel out. And what's remaining, right? This is canceling out. And you end up getting 2, 5 on the numerator, which is going to be 5 squared. That's 25. Let's look at the next one. This one look like you should be able to combine the like base. So look like the one with the 3 first, one with the x. So when you're looking at one with the 3, I should be able to say 3 squared minus 4. And then one with the x, I will say x 5 minus 3. And 3 to 2 minus 4 is negative 2. 5 minus 3 is 2. In your simplest form, you cannot have negative exponents. So it will be 1 over 3 squared times x squared, which gives you x squared on the numerator. Denominator will be 3 squared, which is 9. Let's look at the last one from this lesson. So it's combination of everything that we went over. I see the negative, so I wanted to get rid of the negative first. Then I will have 7 and y squared on the numerator, and I have x squared on denominator. The one that I had negative from denominator with negative exponent from denominator, I can bring up to the numerator. So this 2 become the numerator with a positive exponent. So it will be 2 to the first exponent. This is all multiplications, right? And y to the fifth exponent. The one with the negative on the numerator, negative exponents on the numerator, that will become denominator with positive exponents. Once you get rid of all the negative, I'm going to combine the like base. So look like I will have 2 number. So 2 times 7 on the numerator. That gives me 14. And for y, I have 2 on the numerator. So this is a multiplication because they're on the same numerator, right? So if this is a multiplication, that will be same thing as adding the exponent, which will be 7. Denominator, this 2 is the like terms, and they are multiplication because they are on denominator together, right? So then you're going to add the exponent. So it will be x to the 5th. And finally, I'm going to look at the final solution and see the solution and see if this is okay. I have 1x, 1y, and positive exponents and 1 numbers, right? So look like that will be my final solutions.